So the first part says, which graphs are piecewise? So piecewise graphs are any graphs that are pieced together but still meet the requirement of being a function. So this first graph right here is a piecewise graph because you are piecing together the left function with the right function. So that first graph there is a piecewise. This graph is not a piecewise function. Even though it looks funky, it is not a piecewise because this is one connected curve. The last one is a piecewise. This is that special type of piecewise we talked about. This is a step function, but a step function is still a piecewise function. Okay. Let's do the next example together as a group. So take a minute, read that word problem, identify key information, So it says they're allowed to catch and keep fish up to 5 pounds for a fee of $5. If they catch over 5 pounds, then they must pay $1 per pound. So that means that if you catch any amount of fish from 0 to 5 pounds, your fee is $5. So from 0 to 5, your cost is unchanged. If they catch over 5 pounds, then they must pay an additional $1 per pound. So what that means is that for every pound more than 5, they must pay an extra $1. So that's going to change slightly. Because again, you want your cost if you catch 6 pounds to be $6. So what you have to do is take into account, yes. Yeah, of course. So you have to take into account that yes, you need to be charged that additional fee, but you have to take away the first 5 pounds. So I should have given myself a little more room. But it's going to be 1 times x minus 5 plus 5. says, what is the fee for catching 8 pounds? So 8 minus 5 is 3. 3 plus 5 is $8. What is the fee for catching 3 pounds? Well, again, 3 is less than 5. Anything less than 5 is 5. What is your domain? Can you catch negative pounds of fish? No. So this domain is not all reals because you cannot catch negative pounds of fish. My domain is thus then from 0. So your domain would be 0 to infinity, or x greater than or equal to 0. Now again, you're not going to probably catch more than 100, 200 pounds of fish, but you could. Your range is then a little bit trickier because your range is that lowest y value. So no matter what, if I catch fish and take it with me, what am I paying at a minimum? If I catch any number of fish and I take them with me at a minimum, I'm paying what? Perfect. So my range is at $5 and above. If I take anything with me, it's going to cost me $5. Okay. So let's look at the bottom for the next example that we are going to kind of create on our own. Okay. So what I want to do is kind of create an example with you. So in the middle of that graph, draw in a solid line to cut the graph in half. And on the fourth line down, draw in a line to cut the graph there. So go ahead and copy my pink lines. And then what I'm going to do is create 2 graphs, and I want you to write their equations. So I want you to find the equation of that first line in blue. And then the green. And last, we're going to look at the purple. So this is a piecewise function. It has 2 breaking points. Its domain is all reals. So it has 2 breaking points. Its domain is all reals. And then what we're going to do is write our equations for each of them. So the first inequality is the blue graph right here. It is horizontal. It starts at x equals -1. So your x value is going to be less than -1. Because it is closed, my x is also equal to. Remember that we break the function y based off of the graph. So in this case, my y is flat, and it is at 1, 2, 3. So it would be a -3, comma, x less than or equal to -1. Then we have the green. The green begins at -1 and ends at +1. So my domain for green is -1 to 1. And then what you want to do is look at those open or closed circles. So the first is open, so it's less than but not equal to. Then it is closed, so that is less than and equal to. You're going to look at the graph. This graph has a y-intercept of -1. My points are going down 2 and over 1. So the line has a slope of -2 and a y-intercept of -1. We're going to do the same thing with the red graph. The problem with the red versus the green is that the red doesn't cross. So we still look at its x value. The red starts at +1 and goes to infinity because it has the arrow this way. So x's are going to be greater than 1, but not equal to. We want to look at its slope. So it's going up 1, right 1, up 1, right 1. So it has a slope of 1. If that pattern were to have continued and went left 1, down 1, where would that graph have hit this line? And it would have hit at -1. So you would just go backwards until you hit the line using your slope, and that's how you get your y-intercept. So you just want to draw the graph backwards to find your y-intercept. Better? And then the last, just little vocab, is a review of all the key things you need to know. What is a step function? A step function is a function that is a bunch of horizontal graphs that appear to look like steps. So again, your step function is going to be that horizontal graph. So it's a collection of horizontal segments. An open circle will occur if you have a less than or a greater than. And your solid circle will be if you have a less than or equal to or a greater than or equal to. These are included, not included. So what that means is that these are not in the domain and these are in the domain.